Right now, we are going to talk about a special case called pair data. As Sam observed chickens for several days, he noticed that chickens consume more feed in the morning than in the evening. So he decides to estimate how much more feed do chickens eat in the morning than in the evening. He randomly picks 100 chickens and numbers the chickens 1 to 100. For chicken number 1 and so on, he records how much feed it eats in the morning and how much in the evening and calculates the difference. You guys may get confused with two populations. To identify pair data, you need to see if one population is involved. In this case, we will compare the amount of feed each individual chicken eats in the morning and in the evening. So individuals do matter, therefore we use pair data. While in two populations, chickens are randomly picked, so individuals do not matter. We would consider the group as a whole. Also, in this case, we would use a confidence interval for pair data because we are trying to estimate how much more feed the chicken eat in the morning than in the evening.
As Sam has more experience on raising chicken, he had doubts on whether chickens consume more feed in the morning than in the evening. He randomly picks 100 chickens and numbered the chickens from 1 to 100 for chicken number 1 and so on. He records how much feed it eats in the morning and how much in the evening to find out if the amount of feed each chicken eats in the morning is actually greater than in the evening.
In this case, we will use pair data because each individual chicken doesn't matter. We are trying to compare the amount of feed each individual chicken eats in the morning and in the evening. Also, this question is a hypothesis test for pair data because it is asking about whether the amount of feed each chicken eats in the morning is really greater than in the evening. There is also a special type of hypothesis test which is called chi-square test. There are three types of chi-square tests, which are goodness of fit, independence, and homogeneity. Sam wants to prove whether there are certain days of week that chickens in Strophilus are more likely to lay eggs. He randomly selects a week and 100 chickens and counts the numbers of eggs chickens laid from Monday to Sunday.
Since then, we can know that there's only one population, which is the chicken from Strophilus. And with that, we can also see that there are only one categorical variables, which is the number of eggs that each chicken lay in one of these days. And with that, we can identify it as goodness of fit. There are four types of feed in Strophilus: feed A, feed B, feed C, and feed D. Sam wants to find out if the skin color, black or white, of chickens related to the type of feed they prefer. He randomly picks 100 chickens to find out.
There are two categorical variables in this case. The first categorical variable is the skin color, and the second categorical variable is the type of feed, A, B, C, or D. This case is trying to check if there's an association between the skin colors and the types of feed chickens prefer. So we would use a chi-square test for independence.
Sam wants to find out if the black chicken and white chicken have the same distribution on preference of having music informed. Sam randomly selects 100 chickens and put them in a small room. A line is drawn in the center of the room. Music comes from the right side and it will play for 10 minutes. If a chicken crosses the line towards the right side, then Sam assumes it prefers music.
In this case, we have two groups, the black chickens and the white chickens. And also, we have one categorical variable, which is the preference on music. Therefore, we would use a chi-square test for homogeneity.